So today I'll be presenting on graphene in seawater, and my name is Brianna. So a little bit of background about this is graphene is a single layer of carbon atoms arranged in a hexagonal lattice, as you can see to the right, and it is 2D. It's known for its tensile strength and electrical conductivity. It used to be very hard to produce in large quantities, but now it can be produced by just a simple oxidation experiment in a lab. It has received a Nobel Prize in physics. Both Andre and Constantin from Manchester University in the United Kingdom extracted graphene from graphite, which is just the lead found in pencils. And what they did was they would draw on a table or substrate as seen in the picture to the right, and they would place tape, and it was usually just standard tape, like it didn't have to be masking tape or anything, and they would put it over where they had just drawn, lift the tape, and as you can see, the residue left behind here in this picture was the graphene. So currently there are two methods that are used to desalinate the water, and it's basically that they're trying to develop new techniques to make seawater potable, because these desalination plants are very costworthy. Environmentalists frown upon the current methods that are being used because they use a lot of energy, and it's producing a lot of greenhouse gases that are going into the environment. So for my current event, United Kingdom researchers just discovered a new technique using a graphene sieve. This sieve is basically going to filter out the salt from the seawater, and as you can see in the picture, this is not what a graphene sieve looks like. It's basically a colander that you would use to filter out water and pasta, but it's basically what it's going to look like, except for the holes are going to be a lot smaller, so the salt particles and stuff do not get through. So it hasn't been used yet because it couldn't be used to filter out common salts, which required even smaller sieves, and because the membrane of the graphene would swell, causing the permeable holes to become larger, and so contamination was going through. So that's what a con has been so far with using graphene oxide membranes. But the problem now has been resolved with these researchers. Professor Rahul Ravindran Nair from the University of Manchester, also in the United Kingdom, found that placing walls of epoxy resin, which is a substance used in coatings and glues, on either side of the graphene oxide membrane was sufficient to stop the expansion. So it was not allowing the membrane to swell, and the holes were staying small. So this means that the filtered salt crystals would not go through the membrane, and that the drinking water, it would produce drinking water, and there would be no contamination. So with this new discovery, there's now more possibilities for improving the efficiency of desalination technology. For climate change, the UN predicts that in 2025 that 14% of the global population will suffer from water scarcity. So urban water supplies are going to be destroyed, and if there's a decrease in rainfall and rising temperatures, then there's going to be less water available for people to have. And so basically with this new discovery, it's allowing us to boost our water production, and hopefully that will help if in 2025 this does occur. For societal impact, if this graphene sieve is used, then it's going to be able to aid millions of people who are already without access to clean drinking water, and it's safe and clean, and drinkable water is going to be available to where it's severely limited, and that's basically what the best outcome of any technology would be. So what's next? They hope to test the durability of the barriers and to confirm that the membrane is resistant to contaminated organics, so not just the salt that's coming through in the seawater. And a quote here from Ram Devanthan of the Pacific Northwest National Laboratory. He said that the ultimate goal is to create a filtration device that will produce potable water from seawater or wastewater with minimal energy input. So reducing the energy input is a big struggle that they're having, and if they're able to manage this, then environmentalists are going to not frown upon this technique of desalination, and it'll be supported, and hopefully it'll be used to cure the water scarcity problem. And these are a few of the discussion questions that we'll talk about in class.